For this problem, what we are going to do is evaluate the integral. So let me just say, we're going to evaluate. What we're going to do is use U-substitution. There's a couple things, but when I see a square root, I sort of think, well, shouldn't maybe what's under the square root equal U? It doesn't always work that way. But then I look at another thing is if I do let U equals cotangent X, do I see the derivative of cotangent X lying around here somewhere? Well, we see something like that. Let's see. The derivative of cotangent is what? Well, because it's a cofunction, the derivative will have a negative in front. And then keep in mind the derivative of tangent X is secant squared X. The derivative of cotangent X is negative cosecant squared X. So it's similar to tangent derivative. And for that negative, what I want to do is multiply both sides by -1. So I write negative du as cosecant squared X dx. The thing about the substitution rule and just integration in general is that it's really a situation where if this problem were just changed by a little bit, like if it said cosecant X and not cosecant squared X, you might have to do it in an entirely different way. I don't even want to start thinking about what we would do in that situation. But it is cosecant squared X there, so we can move on. And now it's a little bit of a question of me organizing the page, but just organizing my work. Okay, so what's going on here then? I have integral of so this cotangent X is U, but it's underneath the square root. I have negative du. I'm going to bring the negative to the front. Sorry, I don't know why I put X there instead of U. And then I'll write du. So the negative I bring outside, and I could switch colors to something else. I don't know. Okay. If I am integrating, I need to change this u to the 1/2, or the square root of u to u to the 1/2. Then I use the power rule. So I have 1/2 plus 1 is 3/2. I divide by 3/2. I add c. So I get negative 2/3 u to the 3/2 plus c. And what's u? U is cotangent X. So I put that in there. And there we go. Anybody see anything wrong with that?